specific section, we're going to talk about functions, okay? Our goal is to learn the mathematical definition of a function and explore the idea of a function. All right, so let's start out with a definition. Let A and B be two non-empty sets. A function, do you have a preference of color? You have to talk. No, okay. Let a function from A to B, a function from A to B, hold on one second. The function, so just a quick recap. Let A and B be two non-empty sets. A function from A to B is a rule of correspondence that assigns to each element in set A exactly one element in set B. Okay? The set A is called the domain. It's called the domain of the function. And your domain of your function is the set of all inputs. It's the set of all inputs. Okay? The set B is called the range. It's called the range of the function, and it is the set of all outputs. Okay? So in other words, if you have a ball and you're throwing a ball to someone, you're never confused on who to throw the ball to, right? So that's the idea of a function. You have a ball, throw it to somebody else, what they get is the output, okay? So you have a function. Notation, this symbol here is read as f of x. It's read as f of x. Now, another note, when you're looking at the set of all inputs, your x values can be called, or is typically called, your independent variable. And your output, because it depends on x, is called a dependent variable. Okay, so x is an independent variable, and f of x is a dependent variable. Okay? So let's look at an example. An example here, suppose that we have some x values, 1, -2, and 3. That's a 3. That's an ugly 3. Let's make it a little bit better. And then suppose your y values are 2, 4, and -1. Suppose we send 1 to 2, -2 to 4, and 3 goes to 1. 3 goes to -1. Does that represent a function? Yes or no? You have to talk. Yes, it does. Why? Very good. Each x value has a specific y value. Okay? Now what about this one? Suppose the x values are -4 and -2, and the y values are 1 and 0. Suppose 4 goes to 1 and -2 goes to 1 and 0. Is that a function? No, very good, it's not. Not a function. Why? It has two different outcomes for -2. Very good. Excellent. Now, a note. The range of f of x, and this is mainly to explain notation because you'll see this symbol provided a lot, or you see this set. The range of f is the curly brackets here means the set of all f of x such that x belongs to A. This is read as the set of all f of x such that, the vertical bar means such that x belongs to A. So this symbol means is a member of or belongs to. So this is the set of all f of x such that x belongs to the set A. What questions do you have? Okay, so now what we're going to do is we're going to go through some examples where we are going to identify what the domain of the function is. And the domains, you'll need to remember interval notation. Okay? How many of you remember interval notation?
My bad. Let me.
1? You need a quick refresher? 2? Quick refresher, yes or no?
Yes.
Okay, so I'm going to move this over here and do an aside to give you a quick refresher of interval notation. Are you okay with inequality notation? You have to talk.
Probably not. Probably need a refresh.
Okay, so I'll give you a refresher of both, okay? Interval notation on the left, inequality notation on the right, okay? So parentheses 0 to 1, that means the open interval 0, 1. This means x is greater than 0 but less than 1. On a number line, this looks like open circle, 0 at 1, and everything in between. Closed interval, well, not closed interval, half closed, half open, means you have x is greater than or equal to 0 but less than 1. So you would have a closed circle at 0, open circle at 1, and everything in between. What is the inequality notation for this? You want it? Go for it. Go ahead.
0 is less than x, and then less than or equal to 1.
Good. What does it look like on a number line?
They're both going to be filled in. No, it's going to be, the left one's going to be open, and then the one on the right's going to be closed.
Good. And everything in between. Remember the everything in between. Okay, good. And then this is called the closed interval 0, 1. How do we write that? How do we write that? In inequality notation. Good. 0 is less than or equal to x, but that's less than or equal to 1. And what does it look like on the number line? Both closed. Only both closed? Only both closed? Everything in between as well. You have to remember that everything in between with that. Okay? That's important. That says that, hey, we don't just want the two numbers 0 and 1, we want all the fractions in between as well. That's what that says. Okay? So that's a quick refresher. Remember negative infinity? What does negative infinity mean? Continuous negative numbers or decreasing without bound. Good. What does infinity mean? Increasing without bound, right? Are they numbers? Is infinity a number? No, good. Infinity is not a number. Negative infinity is not a number. They're just symbols used to either indicate increasing with bound or decreasing without bound. Okay? Or increasing without bound. Okay? So you may see this notation. And you can never have equality at those because they're not numbers. Bless you. And it's the entire real number line. Okay? All right. So now that you have that, let's actually go through some examples where we're going to find the domain. Now, here you're going to have to remember basic functions, okay? You'll have to remember basic functions. Do you have the information from the aside? Okay. So I'm going to make this a little bit larger. And now we're going to find the domain. We're going to find the domain of the following. So y equals the square root of 2x plus 6. In order for you to take the square root of a function, what do you know about what's on the inside? What are the restrictions here? It has to be what? Positive, good. Or equal to 0, right? So it can be greater than or equal to 0. So based on that, the domain would be, I'm going to use set notation and I'm going to convert it to interval notation. So it will be the set of all, that's a curly bracket, x, such that 2x plus 6 is greater than or equal to 0. But now what we have to do is we have to isolate the x in this part. So it's going to be the set of all x such that 2x is greater than or equal to what number? So we're taking this inequality and we're isolating x. So that means 2x has to be greater than or equal to what? -6, very good. Or in other words, it's the set of all x such that x is greater than or equal to what? -3, very good. You divide both sides by 2. So, in our inequality notation, that means we have bracket -3, comma, infinity, parentheses. What questions do you have? Yes?
Why'd you do a closed bracket for -3?
Because you have an equal to here. Anytime you have a greater than or equal to or less than or equal to, that indicates you have a bracket.
Okay.
But if it's strictly greater than or strictly less than, you have a parentheses. What other questions do you have? Okay, so let's look at another one. Let's look at part B. Part B says S of t is equal to 1 divided by t squared minus 6t minus 7. Now, let me ask you a question. What are the, if you have a fraction, what can't you divide by? 0. You cannot divide by 0. Good. So if you cannot divide by 0, if we're finding the domain of this specific function, we need to find out where the denominator is equal to 0 and exclude those numbers. Okay, so let's write it out. So just to rewrite this function, we're going to factor that. So this is going to be 1 over, if you factor it, it's going to factor as t minus 7 times the quantity t plus 1. Now, what can the denominator not be equal to? 7 and -1. Good. So I'm going to write d sub S to denote the domain of S, so I don't have to write it out. So what's D sub S? I just said it. I said I'm gonna write D sub S to mean what? Can you hear me okay? Okay, so make sure you're listening to me whenever we talk, okay? And respond to me. D sub S is the domain of S, and I'm writing D sub S so I don't have to write the domain of S, okay? So what's D sub S? The domain of S, okay? So that's equal to the set of all T values such that T is not equal to 7 and T is not equal to -1. Okay, so in interval notation, that means we have all the real numbers except for 7 and -1. So the way we write that is negative infinity to -1, parentheses, union. Union means you're going to add some more numbers to it. -1 to 7, union 7 to infinity. Okay? Yes? So now what we want to do is we want to find the domain of f of x equals the cubed root of x plus 3 divided by x minus 4. So underneath the radical, we can have all kinds of numbers. We can, if it's an odd index here, which is the 3, we can have positive and negative numbers underneath, okay, in our radicand. But the only thing we have to exclude here is what? 4, or where your denominator is what? 0. Good. So you have to exclude 4, very good, or exclude where the denominator is equal to 0. So, what is this? I'll erase that and put, what does that mean? The domain of f of x is equal to, you tell me what to write. Remember, you get participation credit as well.
Domain of f of x,
Such that, so we write a vertical bar.
yes, such that f of x does not equal 4.
Not quite. Go ahead, give it a try.
Is it the set of all, the set of all,
What are you putting in? Are you putting in f of x or are you putting in x? What's your input? Is your input x or is your input f of x? Your input is x, very good. So whenever you're writing your domain is always your input, right? So it's going to be the set of all what? X, there you go. It's the set of all x. Such that what? F of x?
X does not equal 4.
X does not equal 4. X does not equal 4. So keep in mind that whenever you're talking about your domain, you're talking about your inputs. Your inputs are always your x values. If we're talking about the range, we're going to talk about f of x values or our y values. But here, your input is always your x. So your domain is your x values such that certain ones can't be included, or such that you have certain properties. Does that make sense?
Yes.
Okay. All right. So what is this in interval notation? Come on, you can do it. What is this in interval notation?
Negative infinity to 4,
Bracket or parentheses?
parentheses,
Go ahead. Good.
union 4 to infinity.
Good.
Not inclusive.
Very good. Good. That's it. That's it. Very good. So now what we want to do, notice that each of these functions in this example was set up where our input was x and this on the left was in terms of this function. So this value was dependent on whatever x was over here. Now, I'm going to ask us to find the range of this function. So now that I'm asking us to find the range of this function, which is in terms of x, we now have to solve for x to find out what types of y values we're going to get. Does that make sense? Okay, so let's go for it. Let's solve. I'm going to move this up so we can have a little bit more room. So we have y times the quantity x minus 3 equals x plus 2. So we just cross multiply. If you have questions, you're going to stop me and ask, correct? Correct. Okay. So now we distribute the y. So we get y times x minus 3y equals x plus 2. What are we solving for here? What are we trying to isolate? X. Very good. So what should we do? It's okay.
Divide by x.
Divide. Can we divide by x?
Yeah, you can. There's an x on both sides.
But can we divide by it though?
You can divide by negative 3y, right?
Can you divide by negative 3y? It's going to make a mess. It's going to make a mess if we divide by a negative 3y or if we divide by an x, right? Because that's going to make the equation look more complicated by putting an x value here or putting a y underneath in our denominator here. We also cannot divide by variables like that. Go ahead, what were you going to say?
You subtract 2 from the other side?
You can subtract 2. So you'll have yx minus 3y minus 2 equals x. Now what? Your goal is to isolate x. Now what?
Divide by y, x.
No, we can't divide. You're trying to divide by variables. Dividing by variables is illegal. Use algebraic manipulations. Is x by itself? No. What other term has an x? If you have yx on this side, how can you get it with the other x?
Negative.
Subtract it, right? So you'll have good. Negative 3y minus 2 equals x minus yx. They both have what in common? The two terms on the right have what in common? X. Factor it out. So that leaves you 1 minus y times x. So now you want to isolate x. So because you have this quantity here, you can have negative 3y minus 2 divided by 1 minus y equals x. Now, we have x is equal to negative 3y minus 2 divided by 1 minus y. Y cannot equal what in order for this equation to make sense? 1. Very good. Y cannot equal 1. So, what's our domain? Or what's our range? It's the same but flip. What's the range of this? Can't hear you. Every number but 1. How do you write that in interval notation? You are correct. It's every number but 1. So in interval notation, how do you write that? Can you talk louder?
Is it negative?
You're whispering. Be confident. If it's wrong, it's wrong. If it's right, it's right, though.
Is it infinity?
You said, is it infinity?
Yeah.
Is that it? Does infinity include everything but one? Not quite. It's a good try. It's a part of it. You had your hand raised.
Can I ask, like, why is it one?
Okay, so you would have 1 minus y equal to 0. That would make your denominator 0. In other words, 1 would be equal to y, right? So y cannot equal 1 in order for this to make sense.
Okay, thank you.
You're welcome. You want to answer it?
Yeah, I think it goes, open parentheses, no, I think it's negative infinity,
Mm-hmm.
and then 1,
Comma 1.
and then open parentheses, close,
Mhm.
yeah. And then.
Your mask has to cover your nose.
Sorry,
What's the symbol?
union,
Yes.
1, and then parentheses, no, I mean, 1 and then infinity parentheses.
Very good. Very good. That's it. What questions do you have? What questions do you have? Yes. Make sure that you go through your homework whenever you're finding the domain and range because you need to practice with this. Okay, so make sure you go through that, and if you have questions, come and ask me. Okay? Next up, let's talk about how to evaluate the function at the indicated values. Okay, so I've given you a function. Okay, I've given you h of t is equal to t plus 1 over t. If I ask us to find h of negative 1, how do we do that? Plug it in where? For t, good. So you have negative 1 plus 1 over negative 1. That's negative 1. What's 1 over negative 1? Negative 1. So you have 1 minus 1. Good. You get what? Negative 2. Excellent. What's h of 2? Do it in steps. Good. You get 2 plus 1 over 2? 2.5, whereas the whole fraction is a fraction period. Instead of a mixed number, you get 2, you have 2.5, or either as a fraction, what is it? 3 over 2? 5 over 2. It's 5 over 2. 3 over 2 is 1.5. So you get 5 over 2.
In general, for this course, do you want to start the fraction?
Okay. H of 1/2. We substitute in 1/2 this time, right? So then you would have 1/2 plus 1 divided by 1/2. So that's 1/2. What's 1 divided by 1/2? 2. Good. So what do you get for this? 5 divided by 2. Good. H of x minus 1. Does that frighten you immediately? Why? It's the same concept. It's the same exact concept. So the variables, try not to let it frighten you completely, because it's the same exact idea. You're going to take what's inside, you're going to take your argument, and you're going to substitute that in for the variable. Okay? So for this problem, you would have x minus 1, because that's your t, plus 1 over x minus 1. And the only thing we have to do at this point is drop the parentheses. So it's x minus 1 plus 1 over x minus 1.
That's all you have to do, you don't have to.
You gotta talk louder.
That's all
What can we do to it?
I don't know.
We can't do anything with it. We can't do anything with it. It is what it is. We just get that. We just get that. So we end up with an equation. What other questions do you have? Okay, let's do h of 1 over x. That's going to be equal to 1 over x plus 1 divided by 1 over x. What's 1 divided by 1 over x? X, good. So this is just 1 over x plus what? X, good. That's it. That's it. So here you have f of x is equal to x over x minus 4. What is f of 2?
2 over 2 minus 4, which goes up to 2 over negative 2, which becomes negative 1.
Everybody agree?
Yes.
Good. Very good. F of a squared.
It becomes a squared over a squared minus 4, which factors out to a plus 2, a minus 2.
So what's that equal to?
A squared over a plus 2, a minus 2.
Good. Either one is acceptable. The first one or this one. Either one is acceptable. Very good. Yes?
So you don't have to break down the a squared minus 4 anymore, you could leave it at that?
How could you break it down anymore?
Well, just the a plus 2, a minus 2.
That's the only way you could do it. You could only factor that.
Okay.
There's nothing else you can do. Yes?
Fine with the left or the right?
I'm okay with the left or the right. Either one is okay here. What other questions do you have? Okay, cool. So now, let's have a definition. The net change, I'm going to move this over to the left a little bit. Make it a little bit larger. Okay, the net change. The net change in the value of a function f as the input changes from a to b. Notice that a is less than or equal to b. That's important. The net change is given by f of b minus f of a. Okay? Notice that here, a function, the input is changing from a to b with a less than or equal to b. The net change is given by f of b minus f of a. Okay? So now let's look at an example where we have to find the net change. I'll go through them with you, and then you can do one, try it on your own. Okay? So find the net change in the value of the function between the given inputs. F of x is equal to 4 minus 5x, and we want to find the net change from the values from 3 to 5. So, using our formula, that is f of 5 minus f of 3. That's equal to the quantity, I'm going to put parentheses, the quantity 4 minus 5 times 5 minus 4, I'm going to put that in parentheses, minus 4 minus 5 times 3. So we're just putting parentheses around the quantities to make sure we don't make a mistake algebraically. Okay? 5 times 5 is what? 25, good. 4 minus 25 minus, what's 4 minus?
Oh, minus negative 1.
Yes, but let's finish the problem, writing it out, and then take a step to evaluate it all. What's 5 times 3? 15, so you'll have 4 minus 15. Now, 4 minus 25 is negative 21 minus, what's 4 minus 15? Negative 11, good. So that gives us negative 21 plus 11, because subtracting a negative gives us a positive. What do we get? Negative 10. Good. That's it. Now find the net change for h of t. H of t is equal to t squared plus 5 from negative 3 to 6. What's the setup here? You have h of t is t squared plus 5. You want to find the net change in the values from negative 3 to 6.
If you plug it in, you would, write out, h of 6 minus h of negative 3.
Good. H of 6 minus h of negative 3.
And then you would plug in h of 6 first.
You plug in h of 6,
I'm sorry, 6. Into
plug in 6.
And that's, 41.
So you get 41. Does anyone need to see the steps?
Yes.
Okay, so you would say 6 squared plus 5, and then you would subtract from that the quantity negative 3 squared plus 5. 6 squared is 36, so then you have 36 plus 5 is 41. And then minus, what's negative 3 quantity squared? 9, and 9 plus 5 is 14, so minus 14. 41 minus 14 is 27. Good. What questions do you have? Okay. All right, so that's how we find the net change. And now what we're going to talk about, we're going to talk about these functions that have two parts to them or more, okay? If they have more than one piece, then we call it a piecewise defined function. So a definition here, a piecewise defined function is defined by different formulas on different parts of its domain, okay? A piecewise defined function is defined by different formulas on different parts of its domain. For example, we're going to find c of 1 given that c of x has these two parts. It's 39 if x is greater than or equal to 0 but less than or equal to 2. And then it's 39 plus 15 times the quantity x minus 2 if x is greater than 2. We want to find c of 1. In order for us to find c of 1, what do we need to know?
You have to plug in 1 for x.
We have to plug in 1 for x. Which part of the function are we in whenever we're saying x is 1? Are we in this part, part 1, or are we in part 2? Part 1, right? Because 1 is between 0 and 2. Okay, very good. So, c of 1 is equal to what?
39.
39, very good. C of 1 is equal to 39 since 1 is between 0 and 2. So C of 1 is equal to 39. If I ask you to find C of 5, which part of the function would you use? The second part. You got it. So now we're going to go through an example where I give you a function or piecewise defined function with 3 different parts. Okay? So I've given you the following problem. F of x is equal to 3x. Let me zoom in. F of x is equal to 3x if x is less than 0. It's x plus 1 if x is greater than or equal to 0 or less than or equal to 2. And it's x minus 2 squared if x is greater than 2. Find f of negative 5. F of 0, f of 1, f of 2, and f of 5. You want a couple minutes to try it first?
Yes.
Okay. Okay. f of -5, what part of the function are you in? Part 1, 2, or 3? 1, very good. What did you get? -15. Do you need me to write in the steps? Yes or no? Okay. F of 0, part 1 or part 2, or part 3? Part 2. So you're in part 2 because you have this equal to there. Okay? So you're in part 2. Part 2, what's f of 0? 1. Good. F of 1, what part of the function are you in? Part 2. Good. What do you get? 2. Good. F of 2, what part of the function are you in? 2. Very good. What do you get? 3. Good. Notice that you are in part 2 here because you have the actual less than or equal to there. Okay? F of 5, what part of the function are you in? 3. Good. What do you get? 9. Excellent. What questions do you have? Okay. Good. So now we're going to switch gears a little bit. Same idea of a function, that is, we're going to take something and substitute it in for an x value. But here, we're going to learn a different formula. This is a formula that you'll see in Calculus 1. You'll see that appear there. It's f of a plus h minus f of a divided by h. This is called the difference quotient. It's called the difference quotient. Okay? And difference quotients represent the average rate of change in the value of f between x equals a and x equals a plus h. Remember the net change whenever you change from, say, 1 to 3? You take the 3 and substitute it into your function first, and you do f of 3 minus f of 1. It's the same idea, except for here, we're going from a to a plus h. So you substitute in the a plus h first. Okay? So the difference quotient is f of a plus h minus f of a divided by h. This you'll need to know. Okay? All right, let's look at some examples where we apply the difference quotient or where we have to find it. Okay? Now, we're going to find the difference quotient. We're going to find the difference quotient of f given that f of x is equal to 4x plus 3. Now, I've broken finding the difference quotient up into steps here. You don't have to. If you want to do it all at once, you can do that. Okay? This is just what I chose to do to present it to you. So, f of x is equal to 4x plus 3. We want to find the difference quotient. Remember, the difference quotient is given by this. So let's find f of a. What's f of a? What's f of a? Yes, absolutely. You get 4a plus 3. And now we're going to find f of a plus h. So we're going to take a plus h and substitute it in for x. So that gives us 4 times the quantity a plus h plus 3. Distribute your 4, what do you get? Somebody dropped something. Okay, great. I'm glad that was just somebody dropping something. You have 4 times the quantity a plus h plus 3. Distribute your 4, what do you get? Plus 3, good. Plus 3. Now, you want to subtract f of a plus h minus f of a. So we found f of a plus h, that was 4a plus 4h plus 3 minus f of a. what you always want to do here is put that f of a in parentheses, so you'll make sure you will not make any algebraic mistakes. So put that in parentheses, and you'll have your minus 4a plus 3. Now we have to distribute the negative. When you distribute the negative, what do you have? Yeah, good. So you have 4a plus 4h plus 3 minus 4a minus 3. Simplify, what happens? What goes away? The 3's and the 4a's, they can't play anymore. And what are you left with? 4h. Good. Have you all ever heard of the club 4H? It's like a girls thing, yeah. 4H, ha ha ha. Some of you are like, what the heck is up with her? She's crazy. I'm not crazy, I promise you. They had like a clover and it was like 4H, but yeah. Okay, so back to finding the difference quotient. We want to find the difference quotient f of a plus h minus f of a divided by h. Notice that h cannot be 0 because we can't divide by 0. Good. So that gives us 4h divided by h. What happens? H's cancel and you're left with what? 4. Very good. Very good. So do you understand how to do this? Do you need to see another one? Okay. Take a couple minutes. Find the difference quotient for the function here. F of x equals 3x squared plus 2. So to find the difference quotient in steps, f of a is equal to 3a squared plus 2. F of a plus h is equal to 3 times the quantity a plus h squared. All of that plus 2. What is a plus h quantity squared? What is a plus h quantity squared? How many of you do not know? Okay, let's write it out. So a plus h times a plus h is equal to, you multiply your first terms, times your outer, your inner, and your last. So that's a squared plus ah plus ha. AH and HA are the same because we're multiplying. Plus h times h. What's h times h? H squared. Good. So this is equal to a squared plus what? 2ah, good, plus h squared. And then we take that and we substitute that's in here. Does that make sense? Yes?
Why did you square the a plus h and not just a?
Why did we square the a plus h here?
Yes.
Because that's what this says. Here, it says take a plus h and square that quantity. That's what this says. To find f of a plus h, that means you take a plus h and substitute it in for x, and that means you squared all of that. Does that make sense? Okay. What other questions do you have so far? Yes?
Did we not take that 3 distributed into the rest of?
Not yet. Remember, we have to finish writing it first. So we have to add plus 2. Now that we've added plus 2, you would now do what? Now you distribute your 3. So you get what?
3ah plus.
You get
A
3a squared.
plus 6ah
Mm-hmm.
plus 3h squared plus 2.
Plus 2. Good. Good. Now we have to find f of a plus h minus f of a. And that's equal to 3a squared plus 6ah plus 3h squared plus 2. And I'm going to erase this, move it out of our way. Maybe. That's not working. We'll leave it alone then. So we're going to subtract f of a. So that's minus the quantity 3a squared plus 2. So that's equal to 3a squared plus 6ah plus 3h squared plus 2, continue,
minus a squared plus 2
minus 3a squared, continue,
plus 2.
plus 2?
Minus 2.
Which one?
Why is it minus?
Why is it minus?
It's distributed.
Because you have to distribute the negative. Good. So this negative goes there, and it also goes there, so that makes this a minus 2. Okay? Now, what happens? What happens?
The 3a squared cancel out.
They cancel out in,
And the 2's cancel.
and the 2's cancel out, leaving you with,
6AH plus 3H squared.
good. And now, we go ahead and we finish finding the difference quotient. So that f of a plus h minus f of a divided by h is now 6ah plus 3h squared divided by h. The terms in the numerator have an h in common. So we can factor that out, leaving us with 6a times the quantity 6a plus 3h times h, all divided by h. Now what happens? The h's cancel. Good. That was the point of factoring it out. Good. So what are you left with?
6a plus 3.
You got it. That's it. That's your answer. That's your answer. What questions do you have? Yes.
Is that a formal difference?
So now the last page here for these notes is we want to know what are the 4 ways to represent a function. There are 4 ways to represent a function. We can represent a function verbally, which is a description in words, algebraically by writing an explicit formula, visually by a graph, or numerically by a table of values. Okay? So let's go through an example. If you notice, I'm choosing a lot of examples that are examples or problems from your homework set, so you can see examples like that, okay? A verbal description of a function is given. Find A, the algebraic, B, the numerical, and C, the graphical representations for the function. So the verbal description says to evaluate g of x, subtract 4 from the input. What's the input? X, good. So subtract 4 from the input. So that's going to be x minus 4. And multiply the result by 3/4. So for A, you have g of x is equal to what?
X minus 4.
Talk a little bit louder.
Is it X minus 4?
The quantity x minus 4.
And then parentheses 3/4.
Multiply that by 3/4. Good. And the only way you can rewrite it is put the constant up front. You can leave it like that. But that's absolutely correct. Good. B, find a numerical representation. So for that, it just means, okay, if you have different values of x, what are your corresponding g of x values? So we'll find the values for 2, 4, 6, and 8. And so we'll substitute in 2 for x here. When you substitute in 2, you get 3/4 times 2 minus 4. 2 minus 4 is what? -2. Negative 2 times 3/4 gives us
Negative 6/4.
-6/4, or reduced is, say it louder. I heard you mumbling. Say it louder. Yes, -3/2. You just have to talk loud. Good. You substitute in 4, what do you get? You substitute in 4, what do you get? 0, good. Substitute in 6, what do you get?
2.
You get 2 for what's in parentheses, but what do you get overall? 3/2, good. Substitute in 8, what do you get? 3, good. And then you can plot those points and give the graphical representation, which is C. So 1, 2, 3, 4, 1, 2, 3, 4, and then we'll go down 3 because we see that whenever we substitute in 0, if you substitute in 0 here, you'll get -4, which means you'll get 3 times -1, which is just -3. So you'll get 3 here, then you'll go up 3 over 4, and down 3 and over 4. Oh, that's not pretty. Let's make that 4. How about that? And that's your graph. What questions do you have? Okay, so make sure you work through the homework problems for this section, okay? Any questions? Okay, so that's section 2.1.